All right, so if you've ever used an AI coding agent, you know the feeling, right? 1 minute, it's absolutely brilliant, and the next, it does something that just leaves you scratching your head. Well, to really master this tech, you've got to understand its core nature. Today, we're breaking down the 3 fundamental, unbreakable rules that govern every single large language model out there.
I mean, we've all been there. You're having this amazing conversation, the AI seems to get your project inside and out, and then, on the very next prompt, poof, it's like it's meeting you for the first time. Or, how about this one? It gives you a completely different, perfectly valid answer to the same question you asked just yesterday. So what is going on?
And here's the absolute key to it all. These quirks, they aren't bugs, they're not something to be fixed. They are the fundamental rules of how these models operate. Misunderstanding them is the source of almost all the frustration. But once you really grasp these rules, you'll stop fighting the technology and start really collaborating with it.
Okay, let's dive into the most important rule of all. I want you to imagine your AI is this world-class, brilliant expert, but with total and complete amnesia. Every single time you talk to it, it's a brand new start.
So, when we say an LLM is stateless, we mean it literally. It has no memory. It doesn't remember what you told it 5 minutes ago, let alone what you were working on last week. Each time you send a message, it gets processed, a response is generated, and then its memory is completely wiped clean. It is a blank slate every single time.
So, how do chat apps seem to remember things? Well, this slide pulls back the curtain on the trick. It's really just an illusion of memory. When you ask something like, "What's my name?" the app doesn't just send that little question. No, it secretly bundles up your entire conversation history and sends it all back to the model. The model then reads everything from the top, finds your name, gives you the answer, and then instantly forgets it all over again.
And here's what that actually means for you when you're coding. You expect the AI to just know your project, but in reality, it's starting fresh every time. So what's the fix? Well, you have to provide the context every single time. This is exactly why things like AI-first IDEs are so powerful, and why having a file like an agents.md, which is basically a permanent written brief for your project, is so crucial. It's on you to manage the state.
All right, on to rule number 2. If you ask an LLM the exact same question twice, you're probably going to get 2 different but still valid answers. And again, this isn't a bug, it's a core feature. It's best to think of the AI as a creative dice roller.
You see, unlike traditional software where 2 plus 2 always equals 4, LLMs work on probabilities. When it's trying to figure out the next word in a sentence, it calculates the likelihood of a whole bunch of different options, and then basically rolls the dice to pick one from that list. It's not fetching a single correct answer from a database, it's constructing a statistically likely one, and that process has randomness baked right in.
The cool thing is, we can actually control this randomness with a setting called temperature. If you set the temperature to 0, the model gets super deterministic. It'll always pick the most likely next word, which can get kind of repetitive. But if you crank the temperature up, it gets way more creative and experimental, but also a lot more unpredictable. Most systems find a sweet spot right in the middle, around 0.7, to get that useful, creative variety.
Now for us developers, this means you just can't expect the same prompt to give you the exact same code every time. And that makes validation totally non-negotiable. This randomness is what allows the AI to come up with new and novel solutions. But you have to contain that creativity. You need clear specs and solid tests to make sure the AI's brilliant idea actually meets your requirements. This is where a workflow like test-driven development becomes your absolute superpower.
And that brings us to our third and final rule. All that context we have to keep sending back to our amnesic expert, and all those creative, probabilistic outputs, all of it has to fit somewhere. And that somewhere is a very finite workspace.
This workspace is called the context window. Just think of it as the model's short-term working memory. It's everything the model can see in a single go. Your instructions, the whole conversation history, any code files you've provided, and it even has to leave room for its own answer. And just like our own working memory, it has a hard, unchangeable limit.
Now, a top-tier model like Gemini 3 has a context window of 2 million tokens. And that sounds massive, right? I mean, that's like 5,000 pages of text. But you would be absolutely shocked at how fast that space just disappears on a real-world project. Yeah, because think about everything that has to cram inside that window. Your main system prompt, your detailed spec for the task, the entire chat history, all the relevant code files, and the model still needs room to write its own response.
on any reasonably complex project, you're going to hit that limit way sooner than you think.
And what happens when that workspace gets full? Well, things start falling out. The model forgets instructions you gave it at the beginning simply because there's no more room. This is why just dumping more and more context in isn't always the answer. If you give it too much irrelevant junk, the important details get lost in the noise and you get really unfocused results. Your job is to become a context engineer, carefully curating only the most important information. It's all about quality over quantity.
So, there we have it. 3 rules: the amnesiac expert, the creative dice roller, and the finite workspace. The thing is, they're not separate problems. They're all part of one interconnected system. So now, let's look at the pros playbook for how to handle them all together.
This slide really connects all the dots. Because the model is stateless, you need to create persistent context, maybe in an agents.md file. Because it's probabilistic, you have to validate its output, which is exactly what test-driven development is for, right? You write the test first to define what success looks like, then let the AI generate code that passes it. And because the context is limited, you have to get really good at context engineering and writing concise specs. See, the rules of the tool literally define the best workflow.
What this all boils down to is a shift in your mental model. The AI is not a knowledgeable colleague who remembers your project from day to day. Instead, think of it as a brilliant world-class expert who has severe amnesia, and you have to brief them from scratch with perfect clarity every single time. Getting that mindset right is the key to productivity.
And look, mastering these rules isn't just about making your life less frustrating. If you ignore them, there are very real, very practical consequences.
First off, that probabilistic nature means the model can hallucinate. It can generate code that looks totally plausible, but is just subtly wrong. Without rock-solid validation, you're just shipping bugs. And second, remember that every single token you stuff into that context window costs you money. Bad context management doesn't just get you bad results, it directly inflates your cloud bill.
So let's just do a quick recap. The model is stateless, so it has no memory. Your response? You persist context in files. The model is probabilistic, so its outputs vary. Your response? You validate everything, no exceptions. And finally, it has a limited context, a fixed workspace. Your response? You engineer your context with surgical precision, quality over quantity.
At the end of the day, the AI is an unbelievably powerful tool that plays by a very clear set of rules. Once you know those rules, you can design a workflow that plays to its incredible strengths instead of constantly fighting its nature. So the only question left is, are you going to master the game?